Right, grade 10s, we are continuing our journey through functions, and I really hope that it is something that is starting to sink in for you. I know that when functions first come your way, it does feel so abstract, but the more you engage with them, the more you practice, the better your understanding will become. Okay, so we've had a look at the straight line, and we saw that we had a gradient and a y-intercept to work with, and that affected the slope, the gradient, and the direction of the line, and then obviously the y-intercept. And then we met the parabola for the first time, which is this curvy graph here, and we saw that we can either have a happy parabola with a positive a value or a sad parabola. Okay, and this q value, it is the y-intercept, and it also talks about a vertical shift up and down. Okay, and now we're going to learn about a very interesting one, and in fact it might seem the most complex, but I find that when it gets tested, it's often the most straightforward in the way that they ask the questions. So that's the hyperbola, and that's a graph that is formed here in two separate arms. Now the hyperbola is very relevant in real life. In fact, if we didn't have a hyperbola, then you wouldn't be able to wear glasses, and you wouldn't have a TV screen or a computer screen. It has such broad applications in many of the things that we need to see. So if you're working with a microscope, there is some hyperbola maths there behind it. So let's dive in and have a look at what we need to understand about the hyperbola here at grade 10 level. So the first thing that we look at is the standard form of the hyperbola. So what we're looking at now is a over x plus q. So the minute that you see this x here in the denominator, you must think, I'm dealing with a hyperbola. Okay, the a value affects the shape. So let's have a look at that. If a is a number that is positive, so in other words greater than 0, okay, which in maths we just mean positive, then our hyperbola is actually going to occur in quadrants 1 and 3. Okay, and if a is a negative value, so smaller than 0, then the hyperbola ends up being in quadrants 2 and 4. Okay, so that's the first thing that shape tells us. Then the other thing that we can read from our equation is the asymptote. Okay, now at grade 11 level, they're going to add some more information here. But for grade 10, what we need to know is that the y-axis is an asymptote, okay? And the equation of that line is x equals 0. So this graph has an asymptote there. And then the other one is that y is equal to q. This q value is an asymptote. Okay, what is an asymptote, you may be asking? An asymptote is a line that a graph approaches but may never touch. So I always like to picture it as almost like electric fencing on my graph. So the graph can get very, very close to that electric fencing, but it never touches it and it never crosses it. Okay, so that's important to know. And then for the intercepts, what you'll notice is that there's actually only an x-intercept for this graph. And I'll show you why. So to get an x-intercept, we let y equal 0. Okay, so that's the same everywhere. But if you picture the hyperbola and you think about the two asymptotes, the graph is never ever going to cross this line here, y equals q, because that's an asymptote. But another asymptote here is the y-axis, this line x equals 0. And so that's why we can't have a y-intercept for this function. Okay, if we talk about domain and range, it's also super helpful to look at this graph, or this picture of the graph. So domain, remember those are our x values. So what you'll see is this function exists all the way down to negative infinity and all the way out to positive infinity, but it's not allowed to equal that asymptote there. So x is an element of the real numbers, but x is not allowed to equal 0. And then very similarly, what you'll see is that it exists all the way down to negative infinity in terms of y values, all the way up to positive infinity on the y-axis there, but it's not allowed to equal this asymptote. And at grade 10 level, this asymptote is going to change around, so we're just going to call it q for now. So y is an element of the real numbers, but it's never allowed to equal whatever that asymptote is there. Okay, here we are asked to sketch a graph. So sketch the graph of f of x equals 2 over x plus 1. and we need a couple of things. It's good to start and then just look at what the shape of this graph is going to be. So let's talk about that. Shape comes from the a value there. So that's going to be positive. A is positive 2. And so that means we're going to be looking at quadrant 1 and quadrant 3. The next thing we want to do is get those asymptotes sketched in so we don't forget about them. So remember, the y-axis is an asymptote, x equals 0, and the q value here, so y is equal to 1, is another asymptote. So those are two lines that my graph is never allowed to touch. Okay, so I'm going to grab a ruler, make sure that I draw these in nice and straight. So y is equal to 1, that's our one asymptote. Okay, we generally use a dotted line for that. And then the other one is on the axis itself. And then we need to label these. Okay, so that's the line y equals 1. And this is the line x equals 0. So that we are showing that we know the asymptotes. Okay, then we can work out an x-intercept. Remember, we don't get a y-intercept here. But let's work out an x-intercept. And we do that by letting y equal to 0. Okay, so we're going to have 0 is equal to 2 over x plus 1. Let's take this over. It's going to be minus 2 over x is equal to, I'm going to make that 1 over 1. And then we can get a common denominator here. So let's make it x. So times x times x. The goal is, if we can get the denominators the same, then we can drop them. So then we just get a nice easy answer of x is equal to minus 2. Okay, and that, if I check it with what's happening in my shape here, that's good, because I want it in that section of the asymptote and that section over there. Okay, but this is definitely not enough information to draw this graph. Okay, and so what we generally need to do then is we need to either draw up a table method, which is probably going to be the quickest way to do this, or we need to do a point-by-point plotting. Either way, we will eventually get there. So I propose we work out what it's going to be at minus 4 and then also at 2 and at 4 to give us a nice spread of values. Okay, so I've quickly pulled together a little table. At minus 2, we know that it's equal to 0. Okay, so what I'm going to do now to work out at minus 4 is I'm just going to substitute that in there. So we're going to say 2 over minus 4, and that gives us minus a half. And then we're going to plus 1, which takes us up to a half. So I can then plot that point there, minus 4 and a half, which then is enough information in this quadrant to actually draw this arm of the hyperbola. So there we go. Remember, we want to get close to the asymptotes, but we don't want to touch them. And then on the other side, let's substitute in a 2, so it becomes 2 over 2, which is 1. 1 plus 1 is 2, so that's a nice round number there. And then 4, if we substitute in 2 over 4, that's going to give us a half. And then we want to plus 1 to that, so that's going to be 1 and a half. So that's going to be somewhere there between 1 and 2. Okay, and that also is then enough information to plot that curve there. Okay, and then we just need to label this. So this was the graph of f, so we can write an f next to one of the arms and then check that your intercepts are labeled. Okay, that's always very important to do. All right, just to complete here, I drew straight onto the graph. So 2 gave us an answer there of 2, and 4 gave us an answer there of 1.5. Okay, so once you've done it point by point plotting, you can draw your hyperbola there. Okay, over here, we are asked to determine the equation of this function. So the first thing we do is we look at what type of function we are dealing with. Okay, I can see 2 asymptotes and 2 arms, and that makes me think of hyperbola. And so I need to know straight from my heart the equation of a hyperbola. So it's a over x plus q. Okay, that's very important. What I find is that a lot of students are throwing away marks here because they don't know how to start. So very important that you go back to the slide we looked at the beginning and you know the equations of all the different functions that we get. Okay, now what we're going to do as our first step is we're going to substitute in the asymptote. sub in the asymptote. So what we know is that the asymptote is that q value there. So it's minus 1. So then I'm going to say, well, y is equal to a over x minus 1. That's going to be my starting point. And then step 2, what I want to do is sub in another point. Okay, so if we look at this graph, we need to look for a point that is somewhere on this graph, okay? And I've only got this one, and I need an x and a y to substitute in there. So be careful here. We're going to have to put this into coordinate form. So when there's an x-intercept, we know that the y value, or the y coordinate, is going to be 0. So I can then rewrite this coordinate as minus 3 and 0. And I'm going to substitute that in. So in my equation, where I have a y, I'm going to write 0. And where I have an x, I'm going to write minus 3. Okay, if we take that over, we're going to end up with a over 3. It's going to become positive, equals minus 1. And then let's times both sides by 3, because that'll get rid of that denominator. And so a is equal to minus 3. Okay, think about the answer that you got. Does it make sense to have a negative a value? Well, if you look at where this is occurring in quadrant 2 and quadrant 4, then that does make sense. That means a should be negative. Okay, and then finally we can conclude and we can say, well, therefore, y is equal to minus 3 over x minus 1. So we substitute in our a value and our q value, and there we have it. Let's see if we can test our understanding of these graphs just before we sign off for this video. So consider the function f of x equals minus 3 over x minus 1. So this is the one we actually just found the equation of. Here it is, quadrants 2 and 4 because of this minus 3, minus 1. Okay, now they say if g of x, so talking about a new graph, this one here is f of x. There should actually be a label there. If g of x is formed by translating f of x 3 units up, write down the equation of g of x. Okay, so everything here needs to shift up 3 units. Okay, and so the first thing I need to ask myself is what in my equation is going to change, because I now need to write down a new equation that's going to reflect this. Okay, is the shape going to change? No, it's still going to be in quadrants 2 and 4, or at least the region of quadrant 2 and 4 if you think of it relative to those asymptotes, and it's still going to be the same sort of steepness and all of that. So we can bank on that minus 3 over x staying exactly like that. But what is going to change, and what is the most obvious thing to see, I think, is this part. This is going to shift up 3 units, and so that's going to end up, we're going to end up with a new asymptote here at y equals positive 2. And so that's going to be our change there. So g of x is equal to minus 3 over x plus 2. That's the first thing we need to note there, just by translating it, okay? So up would be positive, down would be negative. Okay, so that's the thing. When we translate, the q value changes. Now, this one's really going to get you thinking. If h of x, so another new graph, is formed by reflecting f of x, so we're going to go back to our original graph, and we're going to do some changes there. So we want to reflect f of x in the x-axis. Okay, in other words, we want to now have a graph that is going to sit somewhere here. If you think of a mirror image here about this x-axis, this one is going to go there somewhere. Okay, can you picture that with me? There's our reflection. Okay, so we want an equation. What I'm hoping you notice is that the asymptote, even that, is going to reflect. And so now that you can see it there, you're probably saying, oh, this is becoming quite obvious, eh? The asymptote is now positive 1. Plus, what do we know about the shape, or at least the a value, if the graph is here in quadrant 1 and 3? That means the a value must change sign. Okay, so essentially what I'm doing, I can show you algebraically. I think what we've established is that this is going to become plus 3 and this is going to become plus 1. But what we're doing is we're taking our equation and we are multiplying a minus through. So minus 3 over x minus 1, and then you distribute that, and so it becomes positive 3 over x plus 1. So you can reflect and know that means your overall y value needs to change sign, or even better, through understanding, say, okay, what's going to change? Well, I understand what the a value does, I understand what the q value does, and that is my new equation.